How are you guys? This is your brother man AMG. Um, Today I will want to briefly talk about some aspects of trigonometry. Already in our previous videos we've talked about the basics, some of the basics. Here we'll continue with some basics that will also help us looking at relationship between angles and the side lines of triangles. Now, in today, let's talk about the Pythagoras theory. It's a continuation of trigonometry. Today, I want us to talk about the Pythagoras theory. Now, let's consider a right angle triangle. If we call this side A, call here B, and if we call here C, if we assume that at this point here is theta, then this side that is facing here, we call this A, I mean C, then here A, then here B. Then Pythagoras theory states that the square of the hypotenuse, of which here is the hypotenuse, here is the opposite, and here is the adjacent. It says that the squares of the hypotenuse is equal to the sum of the squares of these other sides. So if here and here is given, you will be able to determine here with this formula. If this and this is given, you can determine this. If this and this is given, you can also determine that. It says the square of the hypotenuse is equal to the sum of the squares of the other sides. Now, making C the subject, this you can have as C is equal to the square root of A squared plus B squared. And in like manner, you can also make A the subject, you can also make B the subject. Now, let's quickly consider some special triangles or ratios of special triangles. Let's consider special triangles or you say ratios of special angles. Special triangles or ratios of special triangles. Now, I'm interested in a right-angled isosceles triangle. A right-angled isosceles triangle. A right-angled isosceles triangle, which is of this form. Of sides 1 and 1. An isosceles triangle is a triangle whose two sides are equal. An isosceles triangle. Now, if it has sides 1, we can always determine this other side using the Pythagoras theory. using the Pythagoras theorem. Then the Pythagoras theorem says c squared is equal to a squared plus b squared. So if that's true, then here we have c, a is 1 squared plus this other side is also 1 squared. Therefore, c squared will be equal to 1 plus 1 equal to 2, so that we have c as the square root of 2. Here is isosceles, right angle isosceles triangle. Triangle. Right angle isosceles triangle. Now, meaning that here is 2, square root of 2. That's what we have. Now, if we assume that here is theta, then we can determine the sine, the cos, and the tan of that angle. The sine of this angle, as we have stated in a previous video, is opposite over hypotenuse. The sine of that angle, theta, is opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. Then you can make a theta the subject. If you make theta the subject, then theta becomes sine inverse of 1 all over square root of 2. And the end result here, the end result is 45 degrees. 45 degrees. In like manner, we can also determine the cos of that angle. The cos of that angle. In like manner, we can also determine the cos of that angle. In like manner, we can also determine the cos of that angle. The cos of that angle will be adjacent over hypotenuse. Same thing, which is 1 all over square root of 2. Therefore, theta will be cos inverse 1 all over the square root of 2, which is equal to the same thing as 45 degrees, which is the same thing as 45 degrees. We can also determine that of the tan of that angle. If we are interested in the tan of that angle, then we have tan theta will be equal to opposite over adjacent, which is 1 all over 1, which is 1. Then theta therefore is tan inverse of 1 equals 45 degrees. So with these that we have, it is clear that sine theta, when theta is 45, sine 45 can be also written as 1 all over the square root of 2. And in like manner, cos 45 is also the same, and tan 45 is equal to 1, based on what we have gotten. Now, if this is true, we can also talk about half equilateral triangle of side 2, half equilateral triangle of side 2. Half equilateral triangle of side 2. Half equilateral triangle. Then this is equilateral triangle, means all sides are equal. If we assume that here is of side 2, here is of, magnitude 2, sorry, of magnitude. If we're interested in splitting this thing vertically to this point, meaning that here is 2, here is 2, assuming that this is the center of that line, then let's say that this angle here is theta. We can also from here determine the sine, the cos and the tan of that angle. If we do that, then we are saying that we have sine theta, which is opposite over hypotenuse. Opposite over hypotenuse. That's what we have. Meaning that we have to determine this point here. From our Pythagoras theory, where we have c squared is equal to a squared plus b squared. This is our c, this is our c, this is our a, this is our b. Then if that's true, c here is 2 squared is equal to a squared, which is 1 squared, plus b squared. Taking this to this other side, here we have 4 minus 1, then we have equal to b squared. So this is 3 equal to b squared, so that b is equal to the square root of 3. Meaning here is the square root of 3. There is the square root of 3. So if we are interested in the sine of this angle, we are saying it is opposite over hypotenuse, which is opposite over hypotenuse, which is 2. So that theta becomes sine inverse of this over this. For that of cos theta is equal to adjacent over hypotenuse, which is 1 all over 2, adjacent all over this, so that theta becomes cos inverse of this equal to. Then for that of tan theta, we have, for tan theta we have opposite over adjacent, So we are saying that that one is equal to root 3 all over 1, which is the same thing as root 3, so that theta becomes tan inverse of root 3 equals what? Now, if you use your calculator to simplify that, the end result that you're going to have there is 60. Here is 60 degrees. In like manner, if you use your calculator for that of the cos, you are going to have 60 as well. 60 as well. You are going to have 60 as well. Now, for that of the tan, where you have tan inverse of 3, you have, if you use your calculator, you're going to have 60 as well. This one is also 60 degrees. So with these that we have, we can say that we can state that sine 60 is the same thing as root 3 over 2. These are special triangles. Then we have cos 60 is the same thing as 1 over 2. And we have tan 60 is the same thing as root 3. Now, if we assume again that the theta here is not here, but rather is subtends it here. If the theta here is our interest, then what do? The sine of this angle then becomes opposite over hypotenuse. The sine there becomes opposite over hypotenuse. The sine of that angle then becomes then become opposites, which is 1 all over 2. We have 1 all over 2. So that theta becomes sine inverse 1 all over 2. Then if you say cos theta, if we are interested in the cos of that angle, that is, we have the cos will be adjacent over hypotenuse. Adjacent over hypotenuse, which is root 3 all over 2. Therefore, theta becomes cos inverse of root 3 all over 2. That's what we have. And this is also equal to something. We are going to use our calculator for that. Then we also have tan theta is equal to adjacent over opposite. Opposite over adjacent. That's what we have for that of tan theta. Opposite, which is 1, all over adjacent, root 3. So that theta becomes tan inverse of 1 all over root 3. Root 3. That's what we have. And the answer is, if you use your calculator, for the first one, if you use your calculator, the first one becomes 30 degrees. It becomes 30 degrees. Whereas cos root 3 over 2, cos root 3 over 2 also is 30 degrees. And tan 1 over 2 is also 30 degrees. This one is also 30 degrees. Meaning that is in this other side, sine 30 is the same thing as 1/2. Then cos 30 is the same thing as root 3 over 2. Then tan 30 is the same thing as 1 all over root 3. So all these are special angles that we have got. So in place of this, you can this. In place of that, you can write that. So we can deal with this thing. We can use them interchangeably. We can use them interchangeably. Now let's look at some trig identities. 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 Trig identities. Trig identities. Then, if we consider a right angle triangle, where the vertex here is A, here is B, here is C, and if we say it subtends some angle at that vertex point, and if here is C, here is B, then here is A, we can determine the Pythagoras of this of this angle, and which is C squared is equal to A squared plus B squared. C squared is equal to A squared plus B squared. But remember that the sine of this angle from the stuccatura, the sine of that angle is equal to, the sine of this angle is equal to opposites over hypotenuse. Opposite over hypotenuse, that is B over C. And the cos of that angle is this over this, which is A over C. And the tan of that angle is opposite over, like I said, which is B over A. That's what we have. Now, from this Pythagoras that we have, if we choose to divide everything by C squared, then we are going to have C squared, then C squared, dividing everything by C squared. Then this becomes 1 will be equal to A all over A all over C raised over 2, this you can write this, then B all over C raised to power 2. But remember that we have said that A over C is the same thing as cos, and B over C is the same thing as sine. So in place of this, we can have 1 is equal to cos theta all squared plus sine theta all squared. This is also the same thing as cos squared theta plus sine squared theta. So this one is the basic trig identity that we have, is the basic fundamental trigonometric identity that we have. Now, having said this, so this thing is very important. This expression here is very important. Having said this, let's try to divide this expression here by cos to see how it looks like. If we divide it by cos, that is 1 all over cos squared theta plus, is equal to cos squared theta all over cos squared theta plus sine squared theta all over cos squared theta. If we divide everything by cos squared theta, here we are going to have, 1 over cos is sec squared. Here we are going to have sec squared theta will be equal to 1 plus tan squared theta. That's what we have. So we are saying that sec squared theta is equal to 1 plus tan squared theta is equal to tan squared theta. If we also choose to divide this same thing with sine, what are we going to have? That is 1 all over sine squared theta is equal to cos squared theta all over sine squared theta. Remember, we are dividing everything by sine squared theta plus sine squared theta all over sine squared theta. The meaning that here we are having cosec squared theta here equals, this one is cos squared theta plus 1. Cosec squared is equal to cos squared theta plus 1 plus 1. Now with these identities, this one that we also have here, we can also do business. This is also very useful. This is also very useful. This one is also very useful. This one is also very useful. This is also very useful. These are trig identities. Very useful tools that can enable us to go through some mathematical joggings. Now, having said that, we can also quickly look at some trig formulas that will enable us go through some simplifying some given problems. Let's look at some mathematical formulas. Established formulas that we can use in problem solving. Now this one is the sum and difference of angles. Sum and difference of angles. Sum and difference of angles. In them we have cos theta plus phi is the same thing as cos theta cos phi minus sin theta sin theta sin phi. Then we also have cos theta minus phi is the same thing as cos theta cos phi plus sine theta sine phi. Then if we are interested in sine sine theta plus phi, then this is also equal to sine theta cos phi plus cos theta sine phi. Then if our interest is also sine theta minus phi, then this we can also write as sine theta cos phi minus cos theta sine phi. Then if we say tan theta plus phi, this we can also write as tan theta plus tan phi, everything over 1 minus tan theta tan phi. Then we also have tan into theta minus phi can also be written as tan theta minus tan phi, everything over 1 plus tan theta tan phi. That is what we have. With these tools in our hand, there is no trigonometrical problem that we cannot solve. And in like manner, we also have some formulas in double angles. Also have some formulas in double angles. This we also have for that of double angles. For that of double angles, this we also have as sine 2 theta is equal to 2 sine theta cos theta. Then cos 2 theta is equal to cos squared theta minus sine squared theta. This one is also equal to 2 cos squared theta minus 1. And this is also equal to 1 minus 2 sine squared theta. So cos 2 theta is equal to cos squared theta minus sine squared theta, and this is also equal to 2 cos squared theta minus 1, or you have it as 1 minus 2 sine squared theta. And you also have tan 2 theta as 2 tan theta all over 1 minus tan squared theta. This you also have. Now we can also talk about sum and difference of ratios. Sum and difference of ratios. Sum and difference of ratios. In that of sum and difference of ratios, we have sine theta plus sine phi is equal to 2 sine theta plus phi all over 2 cos theta minus phi all over 2. That's what we have. Then for that of sine theta minus sine phi, we have it as 2 cos theta plus phi all over 2 sine theta minus phi all over 2. That's what we have. Then if you come to that of cos theta plus cos phi, this we have as 2 cos theta plus phi all over 2 cos theta minus phi all over 2. Then lastly, cos theta minus cos phi is equal to minus 2 sine theta plus phi all over 2, then sine theta minus phi all over 2. That's what we have. Then we can also, someone can also talk about product of ratios. Product of ratios. There are also formulas that enables us for that of product of ratios. Product of ratios. For that of product of ratios, we have 2 sine theta cos phi is equal to sine theta plus phi plus sine theta minus phi. Then we also have 2 cos theta cos phi is equal to 2 cos theta cos phi is equal to cos theta plus phi plus cos theta minus phi. That's what you have. Then lastly, 2 sine theta sine phi is equal to cos theta minus phi minus cos theta plus phi. That's what we have. Now, with all these tools that we have gotten, I'm telling you that, I bet you that we are good to go in terms of handling trigonometrical problems. In terms of trigonometrical problems. Let's consider just one example before we call it a day. Let's consider just one example before we call it a day. A simple one before we call it a day. If we say show that that 1 all over 1 minus cos theta plus 1 all over 1 plus cos theta is equal to 2 cosec squared theta. If you're asked to show that, what do we do? What do we do? This we can solve in a reasonable way. First of all, we take the LCM. First of all, we take the LCM of this side. In order for us to show that this one is equal to this, if we consider the LCM will be taking the product of this and that, taking the product of this and that. And this you have 1 minus cos theta into 1 plus cos theta. Now, this divided by this is left, so you bring this up so that you have 1 plus cos theta, then plus this divided by this is off and you have this, so you have 1 minus cos theta. Now, the next thing you do is to simplify. And when you simplify, you are going to have this one is this and this is off, so you have 2 all over cos 1 minus cos theta into 1 plus cos theta. That's what you have. That's what you have. So what do you do next? What do you do next? But remember from trig identity that cos square theta plus sine square theta is equal to 1. Cos square theta plus sine square theta is equal to 1. Making this the subject, we have sine square theta is equal to 1 minus cos square theta. 1 minus cos square theta. So what do you do? What do you do? You also have that, so from this side, if you open the brackets, from this one, you are going to have, if you open the bracket from this one, you have this to this, you have 1, this to this, you have plus cos, this to this, you have minus cos theta, this to this, you have negative cos square theta. And this is off, and you'll be left with 1 minus cos square theta. So in this place, then you have 2 all over 1 minus cos square theta. And we have established that sine square theta is equal to 1 minus cos square theta. So the next thing that we're going to have is 2 all over sine square theta. We have 2 all over sine square theta. So from here, instead we have 2 all over sine square theta. And this you can further write as 2 dot 1 into sine square theta. And we know that sine square theta is the same thing as cos square theta. This one is the same thing as 2 into cos sec square theta. So with this, you have shown that this plus this is equal to 2 cosec square theta, QED. So there are a lot more that we need to do. Those, they are much, and but pretty simple. All that you need to do is just to know the fundamentals so that you put all these things to work, and you are good to go. I'm so pleased to show you this, though trig is a bit straightforward, but a bit lengthy for people to cram. You don't need to cram, you just need to know how it moves so that you can play with them at every given time. Thank you, and God bless you as you wait to look at other videos.